Okay, so question is given on your screen. A charge of 8 millicoulomb. It is given 8 millicoulomb is located at the origin. Okay, means this charge is fixed at origin, and calculate the work done. Calculate the work done in taking a small charge of -2 into 10 raised to -9 coulomb. It is given value from point P003, that is it is on z axis. 003 means so it is on z axis to point 040 centimeter. It is given here centimeter. Okay, and via point R6 and 9 centimeters. This is the path actually given. From this point they are taking charge from one point to another point. So let's write value. Suppose Q1 is equal to 8 millicoulomb, that is 8 into 10 raised to -3 coulomb. Millicoulomb is given, and Q2, how much Q2 is given? Q2 is given -2 into 10 raised to -9 coulomb. Okay, and we have to find out potential is equal to what. Now see, point, we know that these electrostatic potential, these are conservative and they are path independent. So this data, that is via a point R06 and 9, this is just to given to confuse. Okay, and there is no use of such data if you know the property of electrostatic forces. So basically we have to look at this point from point 003 centimeter to 040 centimeter, means from z to y axis they are taking. Okay, so now we will use calculate. We know that what is potential basically. So potential basically work done per unit charge, and therefore we can write work done is equal to, here potential is changing, change in potential into charge. Okay, this formula we will use. So now what is change in potential? So let me draw this diagram. Suppose this is x, y and z axis. This is origin, and here your 8 microcoulomb charge Q1 is placed, and according to question, where the point charge was initially, from a point 003, so that is on z axis. So suppose this is z axis, so this is z, this is x, and this is y, and this is suppose 3. So here is your charge. So you have to find out what is the potential at this point because of this charge. Okay, so you have, that will give you V1. Okay, now in question what saying, it is taken to point 040 cent, means y axis 4 centimeter. So here they are taking, means then you have to calculate what is the potential at this point because of this charge, because we have displaced this charge, this Q2 displaced to here. So like this, you will displace here at this point. Okay, so you have to find out this del V, V2 minus V1. Okay, so let's calculate V1. So what is basically V1? So V1 is equal to, let me write. So V1 initially it was at 3. So V1 is equal to Q upon, okay, Q upon 4 pi epsilon naught. Okay, that is here Q1 upon 4 pi epsilon naught, and R1 is 3 here. This is 3 and this is 4. Okay, so this is V1. Similarly you have to calculate V2. So V2 Q1, because you displace same charge, so Q1 only, Q1 into 4 pi epsilon naught R2, and R2 is 4 here. Then find out del V. So therefore you can write del V is equal to del V2 minus V1, and then you can apply W is equal to Q1, actually this is Q2, or you can take Q1, no problem. So this is Q1 into V2 minus V1. Now substitute the values, you will get answer. So Q1 is 8 into 10 raised to minus 3, and here 1 upon 4 pi epsilon naught, and this is Q2 is nothing but minus 0.2. So how much given? 2 into 10 raised to minus 9 coulomb. So 2 into 10 raised to minus 9 minus 1 upon 4 pi epsilon naught, and here R is also there, R1, so you have to keep here, and it is 3 centimeters, so it is 0.02, means you can write 3 into 10 raised to minus 2 meter. And similarly here you have to put value 1.4 pi epsilon naught R, that is 4 into 10 raised to 4 into 10 raised to minus 2 meter, and here 2 into 10 raised to minus 9. Now you have to solve this. When you will solve this, you will get your answer. So that is what W is equal to, you will get in joule. Okay, this you have to solve and send the answer. This is the method how you can solve this. Okay, now you can solve this data, and this will be taken as common. Basically 1 upon 3 into 10 raised to minus 2 minus of, and here we have 1 upon 4 into 10 raised to minus 2, and minus, here it is minus 2, and here it is also minus 2. Negative charge is given, so you can calculate. This is the solution of the first question you will get, and you have to solve this and send me the answer. Okay, now we will go for next question. Question number 32 in NCERT it is given. So what is given here, this is, ignore this one because this is what I have taken. So from here it is given question number 2.32. A cylindrical capacitor has two coaxial cylinders of length 15 centimeter. Okay, so let me write data first. So length is 15 centimeter, that is 15 into 10 raised to minus 2 meter, and radii 1.4 and 1.5 and 1.4 is given. So let R1 is equal to 1.4 centimeter converted into meter, 1.5 into 10 raised to minus 2 meter, and R2 is also given 1.4 centimeter is equal to 1.4 into 10 raised to minus 2 meter. Now what is asking, the outer cylinder is earth and the inner cylinder is given a charge 3.5 microcoulomb. Okay, so Q is given here. So one is earth, so Q is equal to 3.5 microcoulomb is equal to 3.5 into 10 raised to minus 6 coulomb. Determine the capacitance of the system and potential of inner cylinder. Okay, so they are asking capacitance is equal to what and potential of inner cylinder is equal to what. Okay, neglect the effect, that is bending of field lines at the end. Okay, so this is not required if because data is given here. This is, see why we are neglecting this bending effect. So because length is very high, see this is 15 centimeter, okay, length of cylinder, and radius is 1.5, so 1.5 centimeter is very less compared to 15 centimeters. So in this case, if length is very high, then you can ignore the bending effect. Bending is basically from where lines of force leave the conductor. Okay, so in this case, formula for this situation is basically capacitance. You can find out. So let me derive this formula, then we will go for solution. So formula basically, suppose I have two cylinders, coaxial cylinder. This is outer cylinder, and one more inner cylinder is there. So this is inner cylinder, okay, and one radius is, suppose this radius of inner cylinder is A and radius of outer cylinder is suppose B, okay, and length is capital L. So we know that what is flux in this case, flux is radial basically, so flux is equal to q by epsilon naught, Gauss theorem. Okay, and what is flux? Flux is basically E dot ds. E dot ds is equal to q. And what is q? See here, this is the cylindrical length. Okay, and here we have to apply lambda charge density, because length wise it is given. So you can write total charge is lambda into its length multiplied by its length divided by epsilon naught. Okay, now what is ds? That is surface area, cylindrical surface, that is nothing but 2 pi rl. So E into 2 pi r, okay, rl. So you can write L here is equal to lambda L upon epsilon naught. So this L will cancel. So you will get E is equal to lambda by 2 pi epsilon naught r. This is, you got electric field. Basically we are deriving the formula for given situation. So now what is potential? So in this case you can find out potential. Integration from inner radius to outer radius minus E dot dr. Integrate this quantity, you will get potential. Okay, and this is the formula basically to calculate potential in case of non symmetrical surface, okay, cylindrical surface. Okay, so solve this. So what you will get basically? So this you will get minus a to b, and E you got lambda by 2 pi epsilon naught r, and here it is dr. So lambda by 2 pi epsilon naught is basically constant, so it will come out. So you can write here. So basically minus a by b, and sorry, to write this directly, take lambda by 2 pi epsilon naught r. Negative sign is basically this negative sign because E and dr are opposite in this case. Electric field and r is opposite. So you can write here a to b 1 upon r dr. Now when you will integrate this quantity 1 upon r, this will give you natural log ln r. Okay, this is the formula for integration. So basically what you will get, you can ignore negative sign here just because at time being. So let me solve this first. So then what you will get? So lambda by 2 pi epsilon naught, and here it is r, and this will give you ln a to b. When you will solve this, so what you will get basically? So you will get potential. Potential is equal to, what is potential in this case? You will get lambda by 2 pi epsilon naught r, and ln b minus ln a, log of log this is upper limit minus lower limit basically. So you will get basically, so this is the potential. You can write here log a minus log b, basically log a upon b. So log a 2 pi epsilon naught r, and ln and b by a. Okay, now what is, so capacitance you can find out. C is equal to q by v. C is equal to q by v. Basically here it is small q we have taken, so you can take small q here. So small q is nothing but basically L into q is equal to L into lambda, and we have to put this value. This value have to keep. Okay, so ln lambda to pi epsilon naught this is lambda by 2 pi epsilon naught r, and ln d by a. This lambda will get cancelled. So finally you will get 2 pi epsilon naught, and this is not r here, because we have differentiated now epsilon naught. So epsilon naught L by ln D by A. This is your formula for capacitor in case of coaxial cylinder. Now every data is given to you. B and A is given, L is also given, this epsilon is constant, 2 pi you know. Okay. Now put the value, you will get answer. So let me solve this. C is equal to basically 2 pi epsilon naught L. Basically you will get 2 into 2 pi into epsilon naught 8.85 into 10 raised to minus 12 and into 0.15. Basically its length is given 15 into 10 raised to minus 0.15 length of the cylinder, and this is ln, and B is how much? It is given 1.5 centimeter. So 1.5 centimeter means 0.015 meter divided by radius of inner orbit 0.014. Now this you can solve with the help of logarithmic table. Okay, and this you can solve. You have to solve this. I am not going to solve this. So you have to solve. You will get some value of capacitance. Okay, basically in farad. Okay, now they are asking potential. So you know what is potential. So potential is nothing but V is equal to Q by C. So V is equal to Q is given by C. So Q you can find out from here. Where Q is already given. 3.5 I think. Yes, 3.5 into 10 raised to minus. Let me see what it is given. 3.5. Yes, it is 3.5 microcoulomb. So you can put the value here. Microcoulomb divided by the value of C you have to put from here. You already got this value. Okay. So put the value of C. You will get in volt. This is the solution of this question, and try to solve this natural log with the help of logarithmic table. Okay, in case any doubt in both the question you can send me. Okay, and thank you for watching this video.